Okay, here's some examples, actually 3 of them, about the second derivative test. Again, we'll be finding the derivative of a curve to help us find where the curve is either concaved up or concave down. If you understand how to use the arrows to indicate when a function's increasing, decreasing, then you already have an idea where the function's concaved up or concave down. I've got the next example. It should look familiar, but notice the arrows again. So here's my original. I got the derivative, and when I graphed it, I came up with my derivative was 0 at -4, 2.5, and 6. Now you might need to pause me, see if you can go find the zeros, graph the derivative, and see if in fact it does have these signs. If you'll notice, my curve is increasing. It maxes out, it's decreasing. I've got a minimum here, it increases, again it maxes, and then it's decreasing. So it says we don't know exactly where concavity is changing. The second derivative, once we set it equal to 0, will give us the x values of the inflection point or points. Inflection points, remember, are where concavity changes. Now before I move on down, if you'll notice, I know it's concave down here. Something's between -4 and 2.5 is occurring in order for it to be concaved up, and then between 2.5 and 6 it's concave down again. So let's go get the second derivative. I did that. I graphed and found the zeros. So here's my second derivative. I've got zeros here and here. My zero on this one is a -1.43. I went all the way to the thousandths place. My zero on this would be 4.430. Now on my second derivative, if you'll notice, to this side of the first zero it's below, so that's where the negative comes from. Between these two zeros it's above, so it's where the positive comes from, and afterwards, after this last zero, it's below again. So here's my second derivative sign chart. Anytime I see a negative, it's concave down. Anytime I see a positive, it's concaved up. I don't do anything at these zeros because that's where my concavity changes. So our original curve is concaved up from -infinity to -1.430. Also, I don't know if I said concaved up. I meant concave down. Also concave down from 4.430 to +infinity. It's concaved up only between -1.430 and 4.430. Now, in order for me to get my inflection points, remember these are my x values, but the inflection points are on my original curve, my original graph. So you need to take these values like you did when you found max min. You take both this x value and this x value all the way back to the original. So store those values, type this in, and see if you come up with those y values. So that's my first example. Next example, I've got a radical. I have to rewrite this to x to the 3/5. So now when I get my derivative, my f prime would be 3/5 x to the -2/5. So either one of these, put it in your calculator, and you should get this picture. Okay? Now if you'll notice, it looks like almost on a zoom decimals, close to it, because if you put this in your standard window, you're fairly far removed. So do zoom 6 to get back to recenter, and then do your window, or zoom 4, sorry. Whew. And you get this. Now this is my derivative. Now guys, because x is in the denominator, and that's one reason I wanted you to see this, because x is in the denominator, my derivative is not defined there. It acts as an asymptote. But if you'll notice, it's positive and positive. This is my first derivative, so my curve is increasing, and then it's increasing again. So now if I go get my second derivative, do it from here, that times that will give me a -6/25 x decreased by 1. There's my -7/5. Now again, 0 is not going to be legal. So if you put this in your calculator, you'll get this picture. Still not defined, but to the left of 0, it's above. To the right of 0, it's below. There's my concavity. So the original curve is concaved up from negative infinity to 0, concave down from 0 to infinity. Inflection point, remember, take the 0 back to the original. It does exist here. The fifth root of 0 to the third is going to be 0. Okay, so now I'm going to go graph the original and see if all of this is true. Here's my original. The curve is increasing on its whole domain. It is concaved up. If you'll notice, this is dished up and this is dished down. Okay, now at this particular place, if you remember back in the very first test, I don't have a tangent line here at 0 because my tangent line is considered vertical. So that's why it doesn't exist. So that's my second example. Third example, I'm going to use my quotient rule. I've got u, I've got v. I went ahead and found my derivative. So you might, check u and v and see if that is actually true. So here it is right here. Oh, sorry, I'm doing my double prime. I didn't have enough room. So there's u, there's v. I had to use chain rule here. And boy, is this a bunch of stuff. But anyway, I did some factoring. If you'll notice, my x squared minus 1 is in both of these terms, so I factored it out so I could try and clean this up a little bit. That canceled with one of those, so I've only got 3 down there, exponent-wise. This on the inside of the brackets did clean up. Anytime you have to use the chain rule in a problem, you're going to have some things that can factor out and more than likely can cancel. So I graphed it, and if you'll notice what I've got here, whoa, because my denominator, I've got that can factor to x plus 1, x minus 1. That's why it's not defined. Those are my vertical asymptotes. This does not equal 0, so this is all I have. But here's my second derivative. It's below to this side of negative 1. Between negative 1 and 1, it's above. And to the right of 1, it is below again. That's where my signs come from. So original curve is concaved up only between negative 1 and 1. Concave down where I've got my negatives. Now the following is my original curve. This little fellow right here. I graphed it down here. Let's see. So there is concavity down in these two locations. It is concaved up, which is what this is telling me. Because it's not defined in the original, that carries all the way through the first derivative, through the second derivative, I don't have any inflection points. There are none. So sort of an odd problem, but that's what I have for this particular one. Okay, so there's some more examples. I think I do 2 more problems in another video, so you might look at those also. Thank you.